Good morning, everybody. Welcome to Natural Science, Grade 8. We're on week 6, and we're going to be learning about the chemical reaction when we apply electricity to a substance. So by the end of this lesson, you'll learn more about the chemical effect and also electrolysis, and I'll explain what electrolysis is. A quick recap on yesterday what we did. We learned that a current causes a magnetic field, such as in electromagnets. So an electric current can be used for making temporary magnets known as an electromagnet. Now moving charges, which is a current, so moving charges are another word for it, is basically a current. Moving charges in a conductor, now the conductor is the wire inside, okay? This causes a magnetic field around it. Now, an electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Electromagnets usually consist of wire wound into a coil and a current through the wire. This creates a magnetic field which is concentrated in the hole, denoting the center of the coil. And as Levi correctly said, it is known as the solenoid. Okay, so we're going to do I asked you to do yesterday an electromagnetic experiment. Did anybody manage to do it? We'll see when you're going to answer these questions now. You may raise your hands. The questions are, what happened when you held the nail over the paper clips? Why are the paper clips attracted to the nail? Did the disconnected nail attract paper, and why? If anybody wants to answer the question, please raise your hand. You can look at the picture here. You have the magnetic field around an electromagnet. So these iron fillings around is the magnetic field. And we took an iron nail and we wrapped wire around the nail in a coil form. Okay, so what happened when you held the nail over the paper clips? Let's see. The paper clip should be attracted to the nail. So if you didn't use iron fillings and if you used paper clips, then the paper clips would have been attracted to the nail. So basically what would have happened is when you applied electric current to this nail, you would have the paper clips clinging to the nail. So because it's both attractive forces. Levi, yes?
For number 2. I'm answering for number 2.
That's fine.
For the paper clips were attracted to the nail because the paper clip has amounts of iron in them.
Okay, very good. So if we had to put it, it has iron in them, so it attracted to it. Okay, well done, Levi.
Thank you.
You're welcome. So now the paper clip was a good conductor of electricity. So when we applied the electric current to the coiled wire, it caused a magnetic field to form. And the magnetic field attracted the metal in the paper clip because it was a good conductor of electricity. Yes, Levi? Hi. Okay. Hi.
May I please also for number 3?
Okay.
The disconnected nail didn't attract the paper clips because there wasn't electrical current in the coiled wire because it didn't cause a but okay, may I please say it in a proper way?
You did say it properly, but you can say it in a different way if you want to.
Okay, the disconnected nail didn't attract the paper clips because there was no electrical current, which means the magnetic field didn't form.
Oh, very good. Well done. Okay, that's an excellent answer.
Thank you.
Okay, thank you for that. So the disconnected nail didn't attract the paper clip because there was no current in the wire, and this means that there was no magnetic field. Well done, Levi. Very proud of you. Okay, so basically what this experiment would teach you is that we need an electric current to cause an electromagnet. Okay, so the electric current caused a magnetic field around it. So for an electromagnet to work, you need an electric current, um, and this would cause a magnetic field around the object. Okay, well done. So now we sorted out electromagnets and we know how an electromagnet is made. We're going to learn about the chemical effect. Okay, so the last effect of an electric current that we are going to look at is how an electric current in a solution. So remember when we spoke about the atoms and stuff in matter and materials, so we're going to go back to that. An electric current can cause a chemical reaction through the process of electrolysis. Now, the fact that you see electrolysis when you look at this word, electrolysis here, now the way it is spelled, you can see electro. So when you see electro, it immediately tells you that you are going to apply or you're going to use some form of electric current in it. So electrolysis means that it has to do with electricity or electric currents. So what we're going to do, we're going to do an experiment. Water can be broken down by electrolysis to produce oxygen and hydrogen gases. And copper chloride solution can be broken down into copper metals and chlorine gases. And this is all through electrolysis. The copper is deposited on one electrode. Now you get a cathode and you get an anode. And the chlorine gas is formed as a bubbles at the other electrode, and that is called the anode. Okay, Levi, you want to say something?
Just for people who don't know what an anode and a cathode is, think of a battery. The cathode is the negative electrode of a battery, and the anode is a positive electrode of a battery.
Well done, very good. Thank you for that, Levi. Very good. Right, so let us investigate the decomposition of a copper chloride. And we're going to investigate focusing on the effects of an electric current. Okay, so what would we need? We'd need a 250 ml beaker. We need 2 carbon electrodes. We will need sandpaper, 3 copper conducting wires, a copper chloride solution, a torch bulb, and a power pack. Now, instructions to do this. You basically need to sand the electrodes with sandpaper to make it clean. Okay, so we take out all the, we clean it up. Then we connect the conducting wire from one electrode to the torch bulb and another wire from the torch bulb to the negative terminal of the power source. Okay, and then we're going to connect the crocodile clip from the second electrode to the positive terminal of the power source. Then we're going to pour 100 milliliters of copper chloride solution into the beakers. And you're going to pour the electrodes you're going to put the electrodes into the beaker and make sure that it does not touch one another. And then we're going to turn the power on. So let me explain what I just said. So here we have the power source. Okay, that's your battery. Then here we have the wire that's holding your battery. And this wire is attached to your electrodes. So this thing here into the solution is going into your electrodes. Okay, and then it's covered with a piece of cardboard. So basically they took cardboard and they cut 2 holes um, uh, in here on the diameter, and they could put the electrodes into the copper chloride solution. And this here is 100 millimeters of copper chloride solution. Okay, so now when we turn the power on, let's see what happens. So when we switched on the power source, what do you think observed in the electrodes? So let's look at this picture here. So this is the anode, this electrode is the anode, and this electrode is a cathode. Okay, so one of the electrodes should be developing a layer of copper, and there should be bubbles developing at the other electrode. So basically they say that in the one electrode you would get a layer of copper around it, and then in the other electrode you'd get bubbles forming around it. So what is happening to the chloride solution when the electric current is passed through it? So we basically want to know, now that we've attached this battery to it, what is happening to this chloride solution. So the copper chloride solution is being chemically separated into pure solid copper and chlorine gas. So this chloride solution is now being separated when we apply heat, and it's now becoming solid copper and also chlorine gas. Okay, so if you switch the power off, now that we're putting the power off, what's going to happen? So the bubbles, so when we terminate the power or we switch the power off, then we know that we are going to know that the bubbles are no longer forming because the reaction has stopped. And then what is causing the separation of the copper chloride? The electric current is separating the copper chloride. So we know that through this experiment, when you had it switched on, what happened? When you had it switched off, what happened? So what we can conclude is that the electric current is actually separating the copper chloride. And then we ask ourselves the question, what would cause, why is it important that you should not leave the carbon electrodes touching each other while the current is flowing? And this is a very good question. They want to know, why should these electrodes not touch each other? So the answer would be, it would cause a short circuit. The electric current will not move through the copper chloride and no separation will occur. So basically, if these two touch each other, it would cause a short circuit. That means it will stop the current from flowing and it will not move through it, and then the copper and chlorine will not be separated. Okay, so we're going to move on, and we're going to discuss more the chemical effect of the electric current. Now, the passage of an electric current through a conducting solution causes a chemical reaction. This may cause formation of bubbles of a gas on the electrodes, and it also causes deposits of metals on the electrodes, and it changes the color of the solution. So I'm going to repeat that again. As the electric current passes through the solution, basically a chemical reaction occurs because now we are adding a current through the solution. And then there's a result. Remember that I taught you previously, in a chemical reaction, you get the reactants and then you get the product. Product is the result, the end result. So the result is basically the formation of bubbles of a gas, which is on one electrode, and then you get deposits of metals on another electrode. And how we see the chemical reaction occurring, remember I told you you use your 5 senses to check the chemical reaction. You use the change of color in the solution shows you that a chemical reaction has occurred. So can you see now how we used everything that we learned in matter and material and we applying it here? So when we go back to do revision, it would make a lot more sense to you, and you'd be able to understand the concept better. So in the above experiment, we learned that electrolysis of a copper chloride is a way of splitting up. Now, another word for splitting up, or a fancy word, is decomposition. So it decomposes, it breaks it down. So it's a decomposition of compounds, copper chloride, using electrical energy. So what we basically did through electrolysis, we decomposed copper chloride using electrical energy. So in the test, if they ask you, through what process do you use to decompose copper chloride? Then you're going to say you use the process which you use to decompose copper chloride is electrolysis. So can you see how they can ask you questions in different ways? Um, uh, so you need to know the content very well so you can answer it. Then the electricity must flow through the electrodes dipped into the electrolyte to complete the electrical circuit with the battery. So now you have to put the electrodes into the solution to complete the circuit. Because if you don't put the electrodes into the circuit, then it's not going to step into the solution. It's not going to separate it. So the electrodes basically flow into the electricity flows into the electrodes, which is into the solution, and it completes the circuit. The separation of the copper chloride means that an electric current can cause chemical reactions to occur. So basically, when we separated the copper chloride, it means a chemical reaction has occurred. And there's many ways in which you can harness this chemical effect for practical uses. So this chemical effect, you can do it in many ways. Okay. So if in the test, if they ask you, define the term electrolysis. Electrolysis is the breaking down of a substance into its component elements by passing an electric current through a liquid or a solution. So I'm going to repeat that again. I'm going to say electrolysis is the breaking down of a substance into components. Okay, so when you say into components, you break it down into each element. Remember, we did elements, and this is by passing an electric current through a liquid or a solution. You could even say liquid solution, through a liquid solution. Okay, so electrolysis is the breaking down of a substance into its elements by passing an electric current through a liquid or a solution. So that's the definition of electrolysis. Does anybody want to put it in words for me, that wants to say it in your own words, or even just read it out again? Levi? You can say it in your own words. Hi, Levi.
Ma'am, morning.
Morning.
I'm just reading it from my textbook.
No. I don't want you to read it from your textbook. I explained it to you. I want you to put it into your own words now.
Okay. Electrolysis is the breaking down of a compound into its elements through using an electrical current.
Okay, and where is this electric current flowing through?
A liquid or solution.
Very good. Well done. So now the fact that you put it into your own words means that you processed it and you can understand it. And when we're studying, We must also not just memorize things, we must understand it, because as we go on to higher grades, it will make our studying easier for us because we understand concepts. Sometimes when we just memorize things and we don't understand it, then when we go to higher grades, it becomes more difficult for us to um, understand. So one of the good ways to basically understand things is basically through drawings. You can do mind maps, you can draw it, you can simplify it. So can you see how when I did this definition here, I broke it up into keywords. So the fact that you can just look at the keywords helps you identify the main ideas in that sentence or in that definition, and then you can understand it better. Okay, right, so we'll continue. We can use electrolysis to purify substances. So now remember that when I taught you, we said we had pure substances and impure substances. Now, pure substances will basically, can you remember what a pure substance is? Does anybody want to try? What makes a pure substance different from a impure substance? Or basically what makes elements different from compounds? Okay, so pure substances will basically, yes, Levi, you want to try?
Ma'am,
Hi,
isn't it a pure substance? It is an impure substance or a pure substance?
pure substance.
Okay, a pure substance is a substance that's not mixed with another substance.
Okay, very good. So basically, it's a substance that has all the atoms that are the same. The number of electrons and protons in each atom are exactly the same. So that's what makes it a pure substance, and it's not mixed with anything else. Okay, well done, Levi. So we have um, how the process of purifying substances is through electrolysis. So we have impure copper can be purified using electrolysis. Now instead of using carbon electrolysis in a copper sulfide solution, we can use copper electrodes. Now, if one of the copper electrodes is a pure copper and the other is an impure copper, then the impure electrode will break down and deposit the pure copper onto the existing pure copper electrode. Okay, so using this through the process of electrolysis, what they did was they took one pure copper electrode and one impure copper electrode. They applied heat to it, and then the copper from the impure electrode, after the heat was applied in the sulfide solution, broke down, and it was attracted to the other electrode that was made up of pure copper. Okay, so one of the most important uses of electrolysis is electroplating. Okay, so we have electroplating. Electrolysis is used to electroplate metals. In the last activity, one of the carbon electrodes was coated with an even layer of pure copper. We say that the carbon electrode was electroplated with copper. And why do we electroplate? Basically, um, an example is to making of jewelry where inexpensive material is made into a ring. For example, when we coat the gold by electroplating. So now it's not really gold, for example. We are just taking another substance and we're coating it over with gold because gold is expensive to buy and lots of people like to wear gold. So they would rather buy the electroplated gold because it's much more cheaper. Okay, so it makes it less expensive for people to wear and to buy. Now the iron rusts easily, and so it is useful to coat it with a layer of zinc to protect it from corrosion. So, like when people make gates and if it's made out of iron, So what they do is that they take, because iron is strong, so what they do is they take a coating and of zinc and they paint it over or they spray it over, and this protects your gate from rusting. So corrosion is basically rusting. And many car parts, bathroom taps, and wheel rims are electroplated with chromium. So they need the iron to make it solid so it doesn't break. But you must know one property of iron is that it rusts quickly because it mixes with oxygen. So what they do is that they coat it. Like for example, we have the iron is coated with zinc, and then we had our bathroom taps and car parts and stuff is coated with chromium. So this protects the item or the object, and it can last for a very long time. So this is why electroplating is very, very important. So I'm going to discuss good conductors, bad conductors, LED, and the heating effect of an electric current. So good conductors basically are electric currents can easily pass through some materials. Like some materials are good conductors of electricity, like you have iron, copper, silver, aluminium, gold. So these are all good conductors of uh, electric electricity. Electric currents can pass through it very easily. Now, bad conductors mean that the electric current cannot pass easily through some materials. Such materials are called bad conductors of electricity, and these are rubber, wood, asbestos, plastics. Now, like in the case of a fire, or if something is sparking at home, or if you placed in a situation where you can see something is overheating and you need to protect yourself, then you use the bad conductors of electricity like wood, rubber, or plastic, and you remove or you separate or you try to break the circuit to prevent it from catching onto fire. You can't just touch it on your own because then you will get shocked, which means that you are a good conductor of electricity. You will get shocked. So basically, you need to uh, use wood, or you need to use rubber, or you need to use plastic to separate objects. You can't just use your hands on your own. Now, you would have noticed, like, because of all the power outages and we have lots of problems with electricity, and coal is a scarce resource on earth because it's been used up, and when you use something up, you can't you can't replenish it. Okay, so we they came up with something called LED. LED means light emitting dioide. Now this LED is enclosed in a glass housing, and it has two wires coming out, and one lead is slightly longer than the other, and the LED can glow even in a weak presence of an electric current. So you would have seen your parents and most people replacing their lights with LED lights, because this allows a weaker current to pass through, and it can still glow. Okay, it still glows brightly using less electricity, and it also reduces your electricity bill by using LED lights. Okay, so it saves your environment, and there's less carbon being used, and it protects our earth from the greenhouse effect. So if you haven't switched to LED lights, then please try and do so to protect our environment. Then we have heating electric effects of electric current. Excuse me. So when an electric current passes through a conductor, it increases the temperature of the conductor. This is called a heating effect of an electric current. Many electric appliances work on heating effect of the electric current. So remember I told you earlier on that we heat, the electric current passes through the wire and it causes the wire to get a bit hot. Okay, and this makes the appliance work. So now we'll also do a magnetic effect of electric currents. Now, when an electric current passes through a conductor, a magnetic field is created around the conductor. And this is called a magnetic effect of an electric current. And this can be demonstrated by keeping a magnet compass near a current carrying conductor. So yesterday we used, in an experiment, we used the magnet around the conductor and we tested to see if it had electricity. And, uh, and you also saw that not only did it have electricity, it had a magnetic field around the wire. So the compass actually tests magnetic fields around the wire, not electricity. So a magnetic compass, it shows the direction when it is placed near a current carrying conductor. The device which works in a magnetic field of current are an electric motor or an electromagnet. So we're going to discuss liquids. Do you think that they are good conductors? So some liquids too can conduct electricity, like tap water, lemon juice, vinegar, salt solution. So most of these liquids conduct electricity and are solutions of acids, bases, or salts. Now, Levi?
Miss,
Yes.
ma'am,
Hi.
isn't it you said that most of the liquids which conduct electricity are solutions of acid, base, or salt? But to check for tap water, isn't it a neutral?
Yes, it did. It is neutral. And uh, one second. I found this in the textbook. I'll just check for you quickly, right?
Yeah.
Okay, so tap water contains some impurities in the form of a mineral. So that is why it is a good conductor of electricity. Now the impurities that it contains is basically salt. Now remember, tap water is not pure water that you are drinking because
Oh.
they add chlorine to it and they mix it with other stuff. So that's why tap water is not pure. It's not pure water. So that's why it is a conductor of electricity. So you would notice like firemen, they don't really use water to put fires off. They use a different type of spray to put fires off. They don't use pure tap water. Okay.
Okay.
Okay. So now you say bad conductors of electricity is distilled water. Now distilled water is pure water, natural pure water. So that is a bad conductor of electricity. So that's very good that you brought it up, Levi. So the difference between, you're welcome, the difference between tap water and distilled water. So tap water is not in its pure form because they chlorinate it and they add salt to it to make it safe for you to drink, because this tap water basically comes from rivers and dams, and it's not like where people are around it and then it gets contaminated on its way. So basically this tap water that we drink goes through a process of filtration and they add chlorine to it and then they make it safe for you to drink it. It's not like the ones that you find in the mountains where it is very, very cold and there's less people there and less and it's not natural. Okay, so you get distilled water. This is a bad conductor of electricity. Also, honey, milk, vegetable oil, these are all bad conductors of electricity.
About milk.
Sorry?
About the milk, probably.
Yes.
Remember. But there's also for the milk. It also shows like the different flavors. For example, long life, full cream, and low fat. And I checked from the milk bottles. It also shows that it's pasteurized and homogenized and all that. What does that mean?
Okay, so now basically milk, it contains lactic acid, and it contains other salts, and um, um, uh, you have long life milk, and you have all these different types of milk is because of the processes that they go through the milk,
Oh,
that they change it. So they adapt it to different environments. Like you have fresh milk, now you can't leave that out, you have to keep it in the fridge. But the
yes,
long life milk is you adapt it to a certain environment, so they process it a bit more different in a different way, so it lasts a bit longer. Because like not some households, even though they would use milk, if there's less people in that household, then it's better for them to buy long life milk because they're using less milk all the time. But in
mm,
households where they have lots of people in it, then they use the fresh milk because it is cheaper than long life milk, um, because it gets finished quickly. Okay,
yes,
okay, thank you. So now tap water conducts electricity because it contains various salts dissolved in it. So it is advised not to touch an electric switch with wet hands. Remember, they always tell you don't, if you have wet hands, don't touch an electric switch because you will get shocked. And this is the reason why, because it is a good conductor of electricity. It contains salts that would electrocute you. So never ever, as a safety precaution, touch um, an electric appliance, that is a plug or anything, with wet hands because you will get shocked. Now, chemical effects of an electric current. In 1800s, a British chemist, William Nicholson, showed that when electrodes were immersed in water and current was passed through it, bubbles of oxygen and hydrogen were produced. And the oxygen bubbles were formed at the electrode connected to the positive terminal, and hydrogen bubbles were formed at the electrode connected to the negative terminal. Okay, when electric current is passed through a conducting solution, some chemical reactions take place in the solution, and this is called a chemical effect of electric current. Some of the chemical effects of the electric current are bubbles of gas, which is which can be formed on the electrode. Then we had metal deposits, which we saw on the other electrode, and the color changed in the solution. Okay, so there was a color change in the solution. So what you need to know Levi?
yeah, it's me.
I
Um,
know.
uh, it's about like the copper chloride solution. About isn't it when it showed like the anode and the cathode? It showed like anions and cations. Are those like particles of the anode and the cathode?
Okay, when I finish this, I'm going to take you to that picture and I'll explain it to you. Is that okay?
Yeah, thank you.
Okay, because it will be better to explain it with the picture so you can actually see it. Okay, so you have homework, and your homework is um, it's on the net for you. If you go to our website, I already put it up there for you, and it's basically what we learned this week. So it's an electrical transfer in an electric system. There are some things that are left blank here for you, and you can fill it in. So I'll go through it quickly with you. We say an electric energy in an electric system in a circuit. When it is closed, we have a reaction, and then you need to fill this in. Okay, and then we say when the circuit is closed, it's a conducting part, and it's made up of certain things. And whatever it's made up of, it has a battery, conducting wires, resistors, and a switch. And the conducting wires has a flow of charges that pass through it, and it is called a current. And the flow of charges moves through a circuit, and this can also cause a short circuit if it is overheated. Okay, so you can download this and you can fill it in, and it will help you to study and help you to understand and memorize things for your exam. So I'm still going to go back to you, Levi. I haven't forgotten. But in summary of today's lesson, just to consolidate what you have learned, a circuit is a system of transferring electrical energy. For a circuit to function, there must be a complete unbroken pathway for the electrons to flow. So a source of energy, cells, or a one cell, or an upload, which means a light bulb or a resistor. Then we use symbols to represent components of an electric circuit so that anyone can interpret the diagrams. And you have a resistor. A resistor is a component in a circuit which resists the movement of electrons through the circuit. And an electric current can heat a resistance wire, and this heating effect is used in everyday appliances like our kettles, our toaster, our irons, the iron that we iron our clothes with. An electric current, this causes a magnetic field, and this magnetic field is used in electromagnets. And we also learned that an electric current can cause a chemical reaction in solutions, and this is called electrolysis, and it's also used to electroplate objects. Okay, all the information from this tutorial was derived from cuvela.com, and the Department of Education uses this site to use their workbooks. You can also visit this YouTube site here, which is, you can take it down, and it shows you how to refine silver through electrolysis. And then you can visit this website for electroplating. So if you need to understand this lesson again, what you can do is you can Google it and you can watch it. So our next lesson basically is going to be on, we're going to do revision from next week. Okay, so I'm just trying to find that picture for Levi. Okay, so basically you have your anode. So this is one cathode, and you have anions. So this anions basically is your breaking down of your where your copper chloride is being separated. Okay, and then you have your cathode, that has cations, and this is your electric solution. So these bubbles and these things that are forming, your anodes and your cations, you'll learn later on more about it. But what you need to know for now is basically it is the chemical current separates the chlorine solution, copper chloride solution, and your anodes are the products of what is broken down here, and your cathode is your like, for example, if you had the copper, impure copper, I'm not using this example now, let's just use the example with the impure copper anode and the pure copper anode. So what happened here is that the impure broke down when we added electricity, and it became your cations, and it was attracted to the pure electrode. Okay, I hope you enjoyed this lesson and you benefited from it. If you want to contact me, you can do so at ahaffeja@gmail.com. And I'll see you next week when we're doing revision. Okay, I hope you have a pleasant weekend, and I hope you benefited and enjoyed this lesson. Goodbye and have a lovely day.